microRNA are circulating in your bloodstream. The unique thing about, so messenger RNA makes protein. So you have a gene, you've got 20,000 genes, they stay inside the nucleus of your cell. They can't leave the nucleus of the cell. And so the DNA unravels a little bit, exposes a gene, a bunch of cofactors and microRNA will bind on there. It will make an RNA, messenger RNA, which will then leave the nucleus and go into the cytoplasm of your cell, and it will code for a protein to be built on top of that. Now contrast this to the microRNA that's from the non-coding or non-gene regions of your DNA, 99%. That 99% that's making the microRNA, they don't stay at home. They go and leave the cell. Not only do they leave the cell, they can leave your body. So right now, if I was to swab your mouth, we could extract these, they're basically envelopes that are in your saliva. They're little exosomes, these little packets of microRNA that are in your saliva right now. And if I go and analyze those, I can tell exactly what genes you're starting to turn on and all of that. And I can tell exactly which microRNA are being activated to modify those genes. The interesting thing is not only in your saliva, it's in your urine, but it's also in your breath. It's also in your sweat. So you've got these exosomes or pockets of data going out into the environment around you. And so if you sit in, a lecture hall over the course of an hour, that professor will actually change everybody's genome in the room by exhaling, by getting these exosomes of microRNA out. Now that's a tiny little bit of information that he's going to exchange with you. In contrast, the bacteria in your gut, the fungi and the rest, we already know is making at least 35% of the microRNA in your bloodstream. 35% is non-human. That's just scratching the surface because we've barely started to really decode the microRNA from the fungi. And already they account for half of that, some 15 to 20% of the microRNA we studied, we already can recognize as being fungal. I think that, just by the sheer numbers that I shared with you a few minutes ago, we are so overwhelmingly outnumbered by the bacteria, the fungi, and the parasites that we're going to find out that 99% of the microRNA in your bloodstream is not from human source. So that's the answer to your question is, how do those bacteria do it? Well, they have junk DNA too, quote unquote. They're making microRNA. They're secreting it into their environment, which is your gut, your sinuses, or your breath. If you walk outside, I live in Virginia. We've got this extraordinary fall going on this year where the colors are just insane and the trees are beautiful and you get that loamy kind of smell in the woods. A lot of that is decomposition, obviously, of the soils and all the leaves falling. That microbiome is exuding exosomes of microRNA. And so every time I go out and breathe, I get to be plastic with my environment, and I get to have the fall tell my body, this is the time for you to reconsolidate. You're going to build strength. I believe that I build better bone in the winter than I do in the summer. I'm putting less of my energy out to my periphery, and I'm starting to go core, just like a tree puts its energy right into its roots during this time of year. So I think I can actually change kind of which organ system is taking the benefit of my fuel, depending on which microenvironment I put myself in.
To watch the full episode or to subscribe to the podcast, click the link in the description or visit us at neurohacker.com/collective insights.